Well, hello there, friends. Do you want to learn an easier way to solve quadratic functions? I've got one for you. Let's go right in. Essential questions. How can I solve the quadratics that do not have the b term? We'll talk about what that means, but I think you might have an idea. Why does a plus or minus sign show up when I use square roots? Let's answer these questions. All right, now example 1. We have a quadratic equation, right? It's a really simple quadratic equation, just x squared equals 4. And you can probably already think of it on your own. Think about it. What squared equals 4? Well, if I square 2, doesn't that get me 4? So clearly x equals 2 is a solution. And we can see that by thinking about how might we cancel the square. What is the opposite of squaring something? Well, we know that the opposite of squaring is square rooting. So if I take the square root of both sides, here I cancel because square roots and squares are opposites. And the square root of 4 is 2 because, again, it's an opposite. It's saying what times itself gives me 4. All right, so we're done, right? Oh, wait. Little Miss Teacher here is saying something. She's saying, hey, don't forget to add a plus or minus sign. So apparently when I take the square root, I'm supposed to do plus or minus 2. What? What does this mean? I don't know. Let's think about this. Yes, if we square 2, we get 4. But isn't it true that also if we square negative 2, we get 4? Remember the whole reason that parabolas are reflected? It's reflected because even if we square a negative number, negative 2 times negative 2 equals positive 4. So this actually has two answers. It has positive 2 as an answer. It has negative 2 as an answer. And the way we write that is we write plus or minus 2 because squaring 2 and negative 2 both results in an answer of 4. Okay, so that's the basic premise behind these problems. Let's take a look at this one. Now notice that I have a square, but I also have some other things first. And if you remember, typically when we're solving, we do reverse PEMDAS. In other words, we try to cancel things that are adding and subtracting, then multiplying and dividing, and then exponents. So let's cancel the addition first. Let's add 14 to both sides. That gives me that 9 squared equals 11. Now we're going to cancel the multiplication and division, so let's divide through by 9. Just so you know, a common mistake at this step is taking the square root right here. You don't want to do that. Work in reverse PEMDAS order. Divide through by 9 first. If you take the square root here, technically you would also have to square root the 9 and it gets confusing. So just divide through by 9 to cancel it. That gives me that n squared is equal to, I'm going to stall for time while I pull up my calculator, 1.2 repeating. And now we know that I can take the square root of both sides. I really need to use my calculator for this. So take the square root of 1.2 repeating. We get n equals 1.10. I'll round it to 0.6. So I'm done, right? No. Don't forget the pretty teacher telling you to add the plus or minus. Mister, I don't get where the plus or minus is coming from. Remember, you can test this out for yourself. Try squaring 1.106. If you square that, you'll get 1.2 repeating. But also, if you square negative 1.106, you will also get positive 1.2 repeating. So there are two solutions here. Another thing that you can remember is typically a parabola maximum can have two x-intercepts. So we need two answers here. One, because when you square a negative, the negatives cancel and give you positive. Okay. Hey, why couldn't I just do this before, Mr. Gregory? Why did I have to do all that complicated factoring stuff? I don't get it. Well, let's compare this equation with this equation. Using square roots method, we'll take a look at this equation first. Using square roots method, it's easy. Hey, I add 9. Ooh, now I have x squared equals 9 because it canceled here. Square root, x equals. I remember that it's plus or minus 3 because if I square negative 3, it also gives me 9. So easy. Yay! But let's try to do that over here, because aren't these the problems that we've been seeing like in the x-intercepts part and in the last chapter? Why can't I just take square roots? Well, let's see. Okay, I'm going to cancel things to the other side. Here I go, subtracting 6, subtracting 9. Okay, good, they cancel. X squared equals negative 6x minus 9. Square root, oh, shoot. How do I take the square root of this? And even if I could take the square root of this, do you see how there's an x inside here? So you're saying that x equals something with x? That's like saying the definition of definition is that it's a definition. It's circular. It makes no sense. So this is what I was talking about way back in the essential question. Notice that this equation over on the left has a b term. Because it has a b term, I am forced to go through the factoring process. It just doesn't work to square root, because if we try, we'll end up with an x in the answer. But this, where's the b term? I have an a term, that's the x squared. I have a c term, that's the 9, but because I don't have a bx, because I don't have this extra x like I do over here, I can reliably take the square root, and look, there's no x in my answer. So this is a simpler way if you don't have the b term. Okay, so let's take a look at this problem. Now this is different than before. The reason why it's different is because now what's being squared is a parenthesis. We're still going to work in reverse PEMDAS. That's how we solve equations. Unless we're doing this very specific thing. Remember, there are special steps for that. But here, it doesn't really look like I have a b term. This isn't even really a quadratic in a form that I recognize. So let's just work in reverse order of operation to cancel things. Well, there's no addition and subtraction except within the parentheses, but we'll consider that within the parentheses. Next, we have to do multiply, divide. So let's divide through by 2. That cancels here. We've talked about that since the beginning of the year, how you can cancel something in front of parentheses. By the way, a common mistake is to distribute. No, don't do that. It violates order of operations because the square, the exponent, would need to come first. So you can't distribute, just divide through by 2. Cancels here. I'm left with 10 equals m plus 5 squared. Now I can worry about canceling the exponents. So let's take the square root of this side and this side. Now, here's where it gets a little tricky. Let's plug square root of 10 into the calculator. I'm getting about 3.16. But remember, every time I take the square root, that square root could also be negative. So I actually have two separate equations emerging. Here's the one where the square root was positive, but also I need one where the square root was negative. Because as soon as I take a square root, just like I did with this problem, right after I take the square root, I need to write plus or minus, because a square root, because when I square a negative, it becomes positive, can be plus or minus. So now it's easy to solve. Let's subtract 5 here. Looks like m is, I'm going to put that into my calculator because I'm lazy, negative 1.84. There's a possible answer. Another possible answer is here. I can do this one more easily in my head. And there we have it. Two different answers. Here's a common mistake that I see. So we'll put this over in the mistake column, and then we'll be done for the day. Here's the mistake I see. After taking the square root of both sides to cancel the square, sometimes I see students doing this. They write the 3.16, which is the square root of 10. Then they subtract 5 and get negative 1.84. And then they're like, oh shoot, I need a plus or minus. There it is, yay, I have my answer. No, not correct. The plus or minus must show up immediately after you take the square root of 10. Be very careful about that to avoid this big mistake of just throwing a plus or minus at the end. Remember, it only shows up because when you square root, it can be plus or minus. All right, so summary. You can't solve equations if this exists. But if, like the problems we've been doing, you have no bx term, if it does not have a bx, you can solve by square roots. Just don't forget the plus or minus right after taking the square root. All right, thanks for watching.